Welcome to my kitchen. Today we are going to be doing an experiment on conduction. Conduction is the transfer of heat energy through different objects. So today we're going to be testing the conduction of wood, plastic, and metal. Right now I want you to make a prediction and see which one you think will conduct heat the best. Take a minute and think about it, maybe write it down. So to do this experiment, if you want to do it at home, you need 3 cups, 3 different spoons, so one that's wood, one that's plastic, one that's metal. You need a cutting board, some butter, something to cut the butter with, a tea kettle or something to boil water in, and water. So our first step is going to be to boil some water. So I'm going to fill my tea kettle. And I'm going to put it on the stove. If you're trying this at home, make sure that you have a grown-up help you with the stove. We want to be safe. While the water is boiling, we're going to cut our butter. So I'm going to use 1 tablespoon of each. So my butter is all labeled for me to tell me how much each section is. So I have 1, 2, and 3. So I cut my entire stick into thirds, a little bit of math coming in with our science lesson. So I'm gonna leave my butter to sit while we wait for our water to boil, and then we'll get started on our next section. So now that our water is boiling, we're gonna turn off the stove, and we're going to remove the water carefully. And we're gonna pour about 2 inches of water into each cup. You kind of have to guess, but we're not filling the cup all the way, just enough. This one needs a little bit more. All right. So we're gonna place each spoon, plastic, metal, and wood, into their own separate cup. I'm going to take the butter and I'm going to stick it onto the top of each spoon. And we're going to see how long it takes each pat of butter to start to fall off of our spoons. So we're going to come back every minute or 2 to check and see how far they've melted and how close they are to falling off, and then see which one melts first and see which is our best conductor. All right, we're about 3 minutes in, and our plastic still isn't really melting. There's a little bit. Our metal has some butter dripping down, and it looks like it's gonna fall off the back pretty quick. Oh, we got some drips going on. And our wood is still just hanging out. It's not really had any change yet, but the metal one looks like it's pretty close. And the plastic's a little bit, but to the touch, the plastic isn't very warm. The metal is warm. And the wood feels like I didn't even put any hot water in there. All right, we're at 4 minutes in. Our plastic still doesn't seem to be conducting very well. Our metal spoon, that butter looks like it's gonna fall any second. It's ready to happen. And our wooden spoon, not a single thing has happened. It's just hanging out. I'll check in another minute and see. I can see the butter dripping down the spoon and see what happens. All right, there we have it. Our metal spoon is falling right off the back. The spoon is actually pretty warm. Oh, oh, oh. There it goes. Down the side of the cup. So our metal spoon seems to be our best conductor. There it is. Of heat. It's all pretty melty, if you can feel it. Our plastic spoon, it is soft. It does look like it would start to fall, but if I touch the spoon, it's actually pretty cool. So the spoon isn't hot at all. And our wooden spoon, it feels like I just took it out of my spoon holder, and none of the butter is melted. So when I touch it, it's not giving me any butter on my fingers. But if I do it with this one, we can see underneath some of the butter comes off, and our metal spoon definitely is the best conductor. So I would say metal, plastic, and then wood. So first place, second place, third place. Thank you so much for joining me in my kitchen today to do a little experiment on heat conduction.
Mrs. Mackes, you did a fabulous job showing us about conduction and how heat transfers up a metal spoon better than it does a plastic or a wooden spoon. We're going to show you another experiment about conduction, and what I have here is a candle, and I'm going to light the candle. Actually, Mr. Jordan's going to light the candle. Don't do this unless you have an adult. I'll hold that. Okay, remember, adults present. Okay, and I have a balloon here. And what will happen if we put the balloon over a candle? It sounds like the heat from the candle will transfer to the rubber or the latex in the balloon, and the balloon will get so hot that it will, well, you know what's going to happen. All right, Mr. Jordan's going to do this because I'm scared. Okay, Mr. Jordan, here we go. Ah! It did it! Ooh, that was scary. Okay, we are outside with this one. We have our candle, and this time Miles is going to show you we have a balloon.
We're filled with water.
But if you could see, if I do this, it's filled with water. So what will happen if we put this water balloon over the candle? We're going to have some heat transfer again. What will happen to this balloon? Miles, what do you think?
The water's going to float.
The water's going to float. Wesley, what do you think?
It's going to pop.
It's going to pop. Mr. Jordan?
It's gonna pop.
It's going to pop. Okay, I'm not holding it. Okay. Okay. One of you hold the candle, or okay, we have the candle going in here. Here comes the water balloon. No, not right on top. Up some. Okay. Oh, it's not popping yet. Can you hold it up, Mr. Jordan? Huh. It's not popping. So, what is going on? Well, I'll tell you what's going on. The heat is transferring to the water instead of the latex. Eventually, this latex is going to let go, but right now, all that heat from the candle is transferring to the water in the balloon and not letting it break. We really want to see it break, though. Let's see. Look at the bottom of it. Oh my goodness. Wait, I didn't see it. There's proof that it is getting hot, but the water inside there, the temperature is raising. Come on, balloon. I'm not so scared with this one.
It's going to get wet.
I don't know. We might have to wait for all that water to get so hot in the balloon that it pops.
Okay, it's recording.
All right, this is how much Mrs. Jordan loves you guys. I am now holding the balloon, and I hate popping balloons. This thing is taking forever to transfer the heat. I'm back inside. I really tried to warm up that water inside the balloon enough so it would pop, but it just wouldn't. So you can see that when we are looking at conduction and the transfer of heat from one object to another, that water is going to be a conductor, but it takes a little bit for it to warm up enough for a balloon to pop. And air made it pop very quickly. It expanded it right away. So that is what we have for conduction, which is the second heat transfer that we have learned about. Next week, we will learn about the third and final way that heat transfers from one object to another. Until then,